So, over quarantine, I decided to start breeding Eastern Hercules beetles, and I decided to see how long I could breed them to be. Now, my original population has a mean length of 50 millimeters and a standard deviation of 10 thirds millimeters. And I'm going to be breeding the top 10% of my population. And I can find the standardized selection point and the selection intensity on a chart, and these values are given to us for the sake of calculation. Now, I have to calculate the truncation point. Any beetle above this number in length is going to be bred together. Truncation point is the average mean, the average length of the original population, plus the standardized selection point times standard deviation. And adding that together gets me 54.273. Any beetle above that length is going to be bred together. I then need to find the selection differential. Easy. Selection intensity times standard deviation, 5.85 millimeters. I then take this selection differential and add it to my original mean in length, and I get the selected population of the original population, and that's going to be 55.85. This is the mean of all the beetles past the truncation point. I then need to find the response to selection, and this is easy to find. The narrow sense times the selected differential gives me the response to selection of 3.9195 millimeters, and I simply add this to the original population to find the mean of the child population, which would end up being 53.9195 millimeters. And as you can see, the original population right here with the second population right here. And you'll notice that this isn't a standard deviation. There comes a point where traits can't quite be pushed any further. See, it might not be feasible for a beetle to get any longer than 60 millimeters. In this case, in the case of the Eastern Hercules beetle, it's kind of pushing it here. They might not be able to survive and molt from larvae into beetles. So at some point, you're not going to be able to push past this wall. Right now, I'm pushing up against it, but eventually it's just not going to be able to be pushed any further. And the beetles will stay the same length from generation to generation.